Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about Boyls temperature. You know, Boyls temperature is very important topic for BSc examinations, both in physics and chemistry. For BSc subsidiary students and honors students of chemistry, it is very important. So let us learn about Boyls temperature. The question is, what is Boyles temperature? You know, my friend, according to Boyles in Charles, the equation of a state for a perfect gas is PV is equal to RT, where R is a gas constant for 1 grams moles. According to this relation, for a given quantity of gas at a given temperature, the value of the product PV determined over a wide range of pressure should be constant. That is Boyle's law. But it was found experimentally by amongst that for air, oxygen, nitrogen and carbon dioxide, the value of the product PV decreases initially with increasing pressure, becomes a minimum at a particular pressure, and then increases with increase in pressure. But for hydrogen, the product PV increases steadily with increase in pressure as shown in figure. Look at this figure for hydrogen and for nitrogen, and this is the graph for perfect gas, but both deviate from this perfect gas. Thus Boyle's law is obeyed only under ideal condition, that is at high temperature and low pressure. Kevon's offer investigating the behavior of various gases suggested that the behavior of all actual gases on compression at constant temperature can be represented by an equation of the type PV plus ABP plus CP square plus dpq dot dot dot, where A, B, C, D are constant for a given term depending on the nature of the gas and are called Wilder coefficient. This suggests that the existence of intermolecular attractions is simply equal to RT, because as P goes to 0, equation 2 reduced to equation 1, the second, third and fourth term becomes negligible in comparison to first at very low pressure, and then gases obey Boyle's law. The coefficient B has a special importance. For all the gases, it varies in a similar manner. Its value is negative at low temperature, but gradually increases to 0 and become positive as the temperature is increased. You know, my friend, the temperature at which coefficient B is 0 is called Boyle temperature, which is represented by TB, because it at this temperature Boyle's law holds over a wide range of pressure provided the constants CD are negligible. Thus at Boyle's temperature B is equal to D by dP, dV is equal to 0 and PV is equal to A, which is constant. Now Van der Waals equation of a state for a real gas is P plus A by V square V minus B RT, equation 3, and this is your equation 2, this is your equation 1, where A and B are called van der Waals constant. So PV minus PV plus A by V minus ABV square is equal to RT. Or in the form of equation 2, PV is equal to RT plus PV minus A by V plus AV by V square, which is equation 4. Approximately, it is written as V is equal to RT by P, equation 5. Putting the value of 5 in 4, PV is equal to RT plus PV minus A by RT P plus ABB R square T square P square. PV is equal to RT and B A by RT and P plus AB R square T square P square. So friends, comparing this equation with equation 2, we get A is equal to RT, B is equal to B minus A by RT, C is equal to AB R square T square, equation 7. At boil temperature, T is equal to TB and B is equal to 0. Therefore, 0 is equal to B minus A by RTB and TB is equal to A by RB. Equation 8. This equation gives the value of Boyle's temperature for all gases obeying van der Waals equation of a state. Clearly, Boyle's temperature depends upon A and B, which are different for different gases. Hence, Boyle's temperature is different for different gases. For nitrogen, its value is 50 degrees Celsius. For hydrogen, it is minus 164 degrees Celsius, and while for helium, minus 250 degrees Celsius. Now, below Boyle's temperature. So, look at Boyle's temperature, above Boyle's temperature and below Boyle's temperature. The value of PV first decreases, as in B in negative, with increase in pressure, reaches a minimum at a particular pressure, and then begin to increase. It is on account of the fact that at high pressure, the term Cp square or dpq, etc. of equation 2 becomes more effective and are positive, and thus PV increases when product of pressure and volume increases with increase in pressure after reaching a minimum. It indicates that below the Boyle's temperature, the gases are highly compressible, and this suggests the existence of the intermolecular attractions. Now, above Boyle's temperature, the product PV increases with increase in pressure from the beginning. Coefficient B is positive above the boil temperature, and thus the terms on the right hand side of equations 2 are positive. As a result, value of PV increases with increase in pressure. It indicates that intermolecular attractions are now less significant. Now, my friends, at boil temperature, the product PV is practically constant for a long range of pressure, but at very high pressure, it begins to increase. Thus, Boyle's law is obeyed over a wide range of pressure. So, my friends, the temperature of inversions I will discuss in later. So, this is your Boyle temperature. So, if the questions like that, write short note on the following and Boyle temperature, you should write these 3 pages in your exams. 4 pages. So, my friends, if you like this type of video, then subscribe my channel, and thanks for watching.